In this module, we'll talk about doing simple mathematics and how numbers work in Python. This will be a relatively short module, pretty straightforward discussion. Python has a variety of fundamental data types. In this lecture, we're going to just stick with numbers. In the next module, we'll talk a little bit about strings, and then we'll move on to complex data types after that. So there are basically three fundamental data types for numbers in Python. You can have numbers which are integers. That should be straightforward: 0, 1, 2, 3, 4, negative values, the counting numbers. Unlike some programming languages, integers in Python have unlimited values, an unlimited range of values. You can make an integer as large as you'd like. In other programming languages, that's often limited, and we'll talk about that in a much later module when we deal with the more advanced mathematical operations. Floating point values are for representing fractional values, and Python stores fractional values using 64-bit floating point numbers, which again we'll get into in a later module, which allows you to basically represent numbers with up to 15 significant figures, and you can represent numbers as large as 10 to the 308th power. So this is sufficient for pretty much all purposes that you're likely to run into on the computer, although there are a few gotchas that we'll need to talk about later on when we deal with those. For those who are into more advanced mathematics, Python also supports complex numbers, where J represents the imaginary number. Okay, let's move into an actual demonstration of using Python as a calculator and number representations in Python. Now, you could launch your Python interpreter by just typing Python at the command prompt, and then it'll tell you what version of Python you're using, and it'll give you this 3-arrow prompt where you can begin to immediately type commands. You'll note that I get Python 3 here. If you use, for example, the built-in Python on a Mac, you may get Python 2 instead of Python 3. In this lecture series, we're going to be talking strictly about Python 3 because there are some differences between them. So make sure that you've got everything installed so you're using Python 3. Now, at this command prompt, we can just type Python commands, and most mathematical operations are just Python commands. We can say 2 plus 2 and see that that's 4. If you specify a number without a decimal point, without any sort of indication that there's a fractional value, the number is going to be an integer by default. Now, if we do something like 3 divided by 2, you'll see that what we get back is 1.5, which is pretty much what you'd normally expect, but that was an integer divided by an integer, and it gave us a floating point number. So there's an additional operation you can use for division if you want to do integer division, which is the double divided by sign operator. And if you give it 2 integers as input, then it will give you an integer as output rounded to down to the lower value. So we can say 9 divided by 4, for something like that. Now, if you want to get the remainder out from the integer division, there's another operator, which is the percent sign or modulus operator, and that will give you the remainder from the integer division operation. So if you use a single slash for your division, you will get a floating point number as an output. If you use a double slash and use integers as your inputs, you will get an integer as an output. And if you want to get the remainder, use percent sign. Plus, minus, we already saw plus up there. Minus works exactly the same way as you'd expect. For multiplication, the character is star. So 5, it's not an X, it's a star. So 5 times 5, obviously 25. There's one other sort of standard Python operator, which is raising something to a power. I can say 5 times 2, and that will be the same as 5 to the second power, and we'll get the same thing we got when we type 5 times 5. Okay, now here I've just been working directly with the interactive Python environment. What we really want to do most of the time in this lecture series is to use the Jupyter Labs environment. So we'll go back to our command prompt, and we'll type Jupyter Lab, and we'll launch Jupyter Lab. That will automatically open up a web browser. And in the web browser, it'll give you this sort of graphical interface, which is running in a window in your web browser. So the graphical interface will allow you to start various applications within Jupyter Lab. One of these is a Python 3 notebook. There's a console, and then there's a variety of other tools depending on what you've installed in the system. What we're going to be using most of the time is this Python 3 notebook. So I'll double-click on that, and that will now give us a notebook tab. You can see it's untitled.ipynb. That notebook will now store all of the commands that I type and all of the results of the commands that I type automatically in this untitled.ipynb file. I can rename it by right-clicking over here if I'd like. I can, for example, call it, let's see, rename, we'll call it test.ipynb, for example. And now anything I do in here will automatically get saved. This environment is very much like software like Mathematica or MATLAB, if you've ever used those before. It's a notebook session where you provide inputs, you execute them, and then you get outputs. So let's just try 2 plus 2 again. And instead of just pressing Enter, I need to press Shift-Enter to make it execute the code. If I just press Enter, so for example, I say 3 times 3 plus 7, and I just hit Enter, it'll give me another line. And I could type additional code in there. If I want to execute it, again, Shift-Enter, and that'll give us the result of our computation. Now everything we've done so far has just been simple mathematical operations. What if I want to do something with variables? So Python supports arbitrary variable names. They don't need to just be simple letters like X or Y or Z. You can have words as variable names. The only restriction on them is that the first character in any variable name has to be a letter, and it can't include any of the built-in words that are part of the Python language. So you can't use a variable called del or a variable called exec, because those are a fundamental part of the programming language. Aside from that, you can do pretty much anything you like. So back in our Jupyter Lab session, you can say, for example, test is equal to 27, and ABC is equal to 18, and Fred is equal to 5. And that's assigned all of those variables. Now if I type test, it'll give me back 27, and I can say test times ABC plus Fred, and I can get back 491. So you can see how the mathematics works. Now, the last thing we need to talk quickly about is more complicated mathematical functions, transcendental functions like sines, cosines, square roots, that sort of thing. Now, if you want to use functions in most languages, you just immediately use them. But here, if I type sine of 0.5 and execute it, I'll get an error. The name sine is not defined. So what's going on here? In Python, if you want to use any of those other mathematical functions, you have to bring them into the language first. And the way you do that is say from math import star. And once you've done that, you can now say sine of 0.5, and it will give you the answer. Now, it may seem kind of stupid that you would have to do this from math import star every time you want to do any math in Python, but there is actually a fairly good reason for this. If I do a square root of -1, for example, I will get an error. Of course, because you can't have a square root of -1, right? Well, not unless you're more of a mathematician and you realize the square root of -1 is the imaginary number, often termed I, sometimes termed J. J typically if you're an electrical engineer, and I if you're a mathematician or a physicist. Anyway, the square root of -1 returns an error in this case. Well, Python has another math library called CMath for complex math. You can say from CMath import star, and after you do that, oops, you can now say square root of -1, and it will tell you that it's 1j. J, again, being the imaginary number. So there are other reasons as well, but that's the main reason why the math functions aren't just built into the Python language. It's treated as a library. That way it can be overridden in various ways if you have very special uses. Later on in the lecture series, we will be talking about NumPy, which is a library which allows you to do much more complicated mathematical operations, and that NumPy library will override some of these mathematical operations in very different ways. So it's important to have this capability. Anyway, that's the basics of math and numbers in Python. Again, there are a lot more complications to this, which we'll get to later on.